Hey everyone, so today we're going to go over the discriminant and the types of roots that we get when we're dealing with quadratic equations or expressions. So from a basic understanding, we know that a parabola, right, the graph of a quadratic equation, can either intersect the x-axis, like right here, giving you two solutions. It can intersect the x-axis once, like in this example, giving you one solution, or it doesn't even touch the x-axis at all, giving you no solutions. But on the Algebra 2 level, you want to go in a bit deeper and try to understand, well, what types of solutions are these? Right? What types of roots are we dealing with? So let's look at an example of something that's imaginary, right? Imaginary solutions. So imaginary. And let's do the example with g of x equals negative 2x squared minus x minus 1. Okay, so when we're trying to determine the types of roots we're dealing with, we need to use the quadratic formula, or specifically the discriminant, which I'll point out in a bit. So let's say we just focus on substituting our a, which is negative 2, b, which is negative 1, and c, which is negative 1, into our general quadratic formula. So that's going to be negative 1 plus or minus the square root of negative 1 squared minus 4 times negative 2 times negative 1 all over 2 times negative 2. And then when we simplify this, it's just positive 1 on the outside plus or minus, and then this inside ends up being a negative 7 all over 4. Okay, so we covered in the previous videos that when we have a negative underneath the radical, we're going to automatically get imaginary solutions. So we can just simplify this into 1 plus or minus. We know that negative 7 is composed of negative 1 times 7. We know the square root of negative 1. Let's write it up here. Sorry, let's write it over here. We know that the square root of negative 1 is equal to I by default. This is a fact. So we can just break this up into I square root of 7 all over 4, which means our solutions are going to be imaginary. Now, instead of plugging this all in to the quadratic equation, if you just want to test the type of root that you have, you can just use what's underneath the radical, which is called the discriminant. So b squared minus 4ac. We plug all those values in again, we get negative 1 squared minus 4 times negative 2 times negative 1. Well, that gave us negative 7, which is less than 0. So any value that's underneath the radical, that's any value of the discriminant that's less than 0, those will always be imaginary. Okay, let's move on to another example. Let's say we look at the function f of x equals x squared plus 5x plus 2. Okay, so if we plug in a equals 1, b equals 5, c equals 2 into our quadratic formula, then we get negative, there's going to be a negative out here. So negative times 5, because it's negative b, plus or minus 5 squared minus 4 times 1 times 2 all over 2 times 1. Now, if we focus on the discriminant only, we're going to get a positive value this time. Negative 5 plus or minus, that value is going to be 17 all over 2. So if we put it to the side here, b squared minus 4ac, which was 5 squared minus 4 times 1 times 2, that ends up being 17, that ends up being greater than 0. So, okay, if it ends up being greater than 0, then we definitely have real solutions. But how will this look like if we break it down even further? So let's do x equals negative 5 plus, let's call this x1 because I'm actually going to split it now. Negative 5 plus the square root of 17, and then over 2, and then x2 equals negative 5 minus the square root of 17, and that's all over 2. Well, if I actually plug this into the calculator, I'm going to get x1 equals negative 0.4384 ... and then x2 will be negative 4.5615 ... So these end up being different solutions, but they are still real. So what happens when our number is greater than 0? we end up having real and unequal solutions. Now there's another term that we can throw in here, which is rational or irrational. So let's look at this value. This is 17. This is a prime number. This is also not a perfect square. So another fact is that whenever you have a non-perfect square underneath the radical, you will always get irrational numbers. So that means this is always irrational as well. Now let's look at something where we do have equal solutions. So let's look at the function. Bring this back down here. H of x equals 9x squared plus 6x plus 1. A equals 9, B equals 6, C equals 1. Let's just focus on our discriminant now for AC. So our B is 6 minus 4 times 9 times 1. And we end up getting 0 equals 0 in this case. All right, that's pretty cool. So what does that look like? If I were to plug this back into the formula, and I'm just doing this just to show you what the solutions would look like. You wouldn't necessarily have to do both on the on any type of exam or anything, or specifically the regions. But this is just to show you why the roots are classified the way they are. So let's just quickly write this down. All over 2 times 9. We know this is going to be plus or minus the square root of 0, pretty much, over 18. And we know the square root of 0 is just 0, so this is negative 6 plus or minus 0 over 18. Now when we split this up, we get negative 6 plus 0 over 18. We get negative 6 minus 0 over 18. That ends up being the same value. They're both going to give you negative 1/3. So when our discriminant equals 0, we get real, rational, and equal roots. Only when the discriminant is equal to, the discriminant is 0, do we get this type of situation. Okay, let's say the discriminant is not 0, but it is a perfect square. As I mentioned before, in the other example, we had a non-perfect square. So let's see. I'm going to call this p of x, and the function is x squared plus 3x minus 4. So a equals 1, b equals 3, c equals negative 4. If we look at the discriminant, b squared minus 4ac, we have 3 squared minus 4 times 1 times a negative 4. Well, that gives us 25, which is not only greater than 0, but a perfect square. So if we were to look at what the solutions break down to, x equals, let's see, negative 3 plus or minus, type in the discriminant again, not type it in, but write it in. So we have this, all over 2 times 1, x equals negative 3 plus or minus square root of 25 over 2, x equals negative 3. We know the square root of 25 is just 5, so that's over 2. So let's see what the solutions will look like if we simplify them, break them down. Negative 3 plus 5 over 2. x2 is negative 3 minus 5 over 2. So this is going to give you negative 3 plus 5, that's 2. 2 over 2 is 1. x2 is negative 3 minus 5, that's negative 8. Negative 8 over 2 is negative 4. So when we break this down and we see what the results are, whenever we have a perfect square, we're going to get real, rational, and unequal roots. Now some of you might say, well, rational numbers, aren't they always fractions? Well, you can pretty much write these over 1 since they're whole numbers, and you still can classify them as rational numbers. And that's pretty much it. Those are the 4 ways of describing the types of roots you have for quadratic equations or expressions. And if you have any more questions or concerns, leave them in the comment section below. Like and subscribe. Bye!